Hi, last time we talked about how to describe the distribution of a categorical variable. So I've got a list of categories, and some people are in those categories. And the way we summarize that is we counted the number in each category, and then we divided by the total to get the proportion in each category. Well, today we're going to be talking about describing the distribution of a quantitative variable. All right, so let's look at our data table. Last time we were looking at this list of used hybrids that were for sale. And we're going to talk about summarizing mileage. Now, if we look at mileage, it's got a bunch of different values. So it wouldn't make sense to count how many mileages were 47,002, how many were 67,054. So what we're going to do is we're going to break up this range of values into equal intervals that we call bins. So the smallest mileage in this list is 47,002. The biggest is this 180,195. So what we're going to do is we're going to split the data up in that range from 47,000 to 180,000, and then we're going to count the number in each range, and then to get a proportion, we'll divide by the total. And when we do that, when I create this interval, these bins, and I create what's called a histogram, I get this graph, right? So this is a histogram. And this histogram breaks up the data into equal width intervals that are from here to here. All right, so I got one to there, and that width, all right, this width, which is called the bin width, is 20,000 miles. And so each of these intervals is called a bin. So I've got 1, 2, 3, 4, 5, 6, 7, 8 bins. There's one car in the first bin. There's one car that has between 40 and 60,000 miles. And the next bin, there's 6 cars that get between 60 and 80,000 miles. And so this is how we summarize a quantitative variable. So here, the bin width is 20,000 miles. All right, so here's some questions about that histogram, which is the graph of a quantitative variable. How many cars have fewer than 100,000 miles? All right, so where do we find 100,000? So 80,000 here, 120. So 100 would be right in the middle of those two. So this line represents 100,000 miles. Everything to the left has fewer than 100,000 miles. Everything to the right has more. So how many cars are to the left? So I've got one car that's between 40 and 60. I've got 6 cars that's between 60 and 80. And I have 7 cars between 80 and 100. So all of those are less than 100. So I've got 7 plus 6 plus 1. That is going to be 14. 7 plus 6 plus 1 equals 14 cars have fewer than 100,000 miles. All right, so there were 20 cars in my list of hybrids. So what is the percent or the proportion of cars that have fewer than 100,000 miles? So again, in order to get a proportion, I'm going to take a count divided by a total count. So here, 14 cars is my count of cars that get fewer than 100,000 miles. 20 cars is my total count. So this percentage that I'm looking for is going to be 14 divided by the total. And that actually equals 0.7, which is 70%. So 70% of the cars get fewer than 100,000 miles. Now, like the bar graphs, histograms follow the area principle. And if you remember what that meant, the area principle was that the area of the bars should be proportional to the counts. And here are the counts in each bin. All right, so the height of these rectangles, these bins, these bars, are the counts. The widths are all the same for each one. So the area of these bars is proportional to the counts. So what that means is that I have 70% of the cars that are to the left of 100,000. That also means 70% of the area, the shaded area, is also to the left of that line.